Hey Chem Kids, Campbell here. We're going to do a real quick video on reaction energy diagrams. So you've seen these before, right? You saw them in our first video when we talked about collision theory, and I showed you the difference between an exothermic reaction and an endothermic reaction for an energy diagram. I identified what the activation energy was on the diagram. In our last video, right, you saw this picture where we identified where the activated complex or transition state is, and you're going to have to be able to label those parts of an energy diagram. So you're going to have to be able to recognize that the first line, the flat part, are our reactants. You're going to have to recognize that at the very top of the peak is our activated complex, which you could call a transition state. That is fine. And that the bottom, the very end, I shouldn't say the bottom because in an endothermic reaction it would be high, but in this diagram, the very last piece is the products. And then there's one other thing you'll need to identify, which is the activation energy. Activation energy. Oh, that's looks beautiful, doesn't it? I'm so good. So this is just a simple one-step reaction. But in our last video, we talked about different multi-step reactions. So let's take a look at a multi-step reaction. And I want you to label this on in your notes. So here I have, again, the reactants. So the first thing that happens here is I have our reactants. So on your diagram, that's number 1. At the top of our hills, right, that is our activated complex. So on your notes, that's number 2. Now, remember that activated complexes and intermediates are different things. An activated complex is a high energy temporary structure where old bonds are breaking and new bonds are forming. And an intermediate seems like it's kind of like that, but you'll notice the intermediate here is down in the valleys. So the intermediate is a product. It's an actual chemical substance that forms and may actually last for a little while before it gets used up and becomes a reactant in a later step. So remember, intermediates were products, then they were reactants. And they occur in the valleys of our energy diagram. We have our products here at the very end. So the last bump is, or the last, not the bump, but the last flat spot is our product. And then our areas in here, these little areas here, those are the areas for the activation energy. So that's number 5, activation energy. You also will need to be able to look at one of these and say, is it endothermic or is it exothermic? So what you want to look at is where this is an energy diagram, right? This is energy here. So you want to look at the energy of the reactants versus the energy of the products, right? So this is, reactants are higher than the products. So that makes this an exothermic reaction. Now, another thing you'll have to do is figure out how many steps are in a reaction. So if we go back to this page, right, this is a one-step reaction. Notice it's one step. So what do you think about this one? How many steps do you think there are in this one? Well, there's 1 step, there's 2 steps, and there's 3 steps. So this is a 3-step reaction. How do you know? All you got to do is, I like to say, just count the bumps. Count the bumps. 1 step, 2 step, 3 step. Boom. All you got to do. All right. So that's all you have to be able to do with these energy diagrams is label it, determine is it endothermic or exothermic, and then how many steps. So how about you do this one? Number 1 refers to this spot right here, which should be flatter. Number 2 is up here. Number 3 is in this valley. Number 4 is up here. Number 5 is there. And I'm going to add another one. I'm going to add number 6. So identify those parts for me. Pause the video or not. All right, if you said number 1 was the reactants, you're right. Number 2 is the activated complex. Number 3, right down in the valley, that's our intermediate. Number 4 is another activated complex. Number 5 is the products. Number 6 is the activation energy. Is this an endothermic or exothermic reaction? Well, dang it. It's another exothermic. Let me draw what an endothermic reaction would look like, just in case you've forgotten. So if I have an endothermic reaction, no, an endothermic reaction maybe would look, I don't know, those are really lovely bumps. But so here are my products, and then here are my reactants. So, sorry, here are my reactants, and here are my products. So the products are higher in energy than the reactants. So that's just really ugly, isn't it? Let's try a one-step reaction. That's a endothermic reaction, something that looks clearer than my mountain diagram right there. How many steps does this, not to ignore those, how many steps is this reaction? Well, you just count the bumps, right? 2 steps. Cool? Got it? All right. If you have any questions, just send me an email.